Hello guys, hope you're doing well. In this video I will be talking about periodic table and periodic law worksheet. So please check out the Dilara Khanum's uh, periodic table scoring package as I told you in the announcement, and check out this video. Everything should be clear for your Bellering quiz. So for this one I'm gonna upload this file again. I took it from your PPT. So I got the periodic table with different kind of informations on them. And here, let's go with the first question. It's telling us choose the incorrect expression about the modern periodic table. So it says that in periodic table, we said that how many periods do we have? So we got here 1, 2, 3, 4, 5, 6, 7. So we got 7 periods, and then we got, if you check this out, we got 18 number 18 in here. So we got 18 groups. So this is right. This is right. Chemical elements are placed there according to mass numbers. We know that it's not the mass number, it's atomic number. So this is one of the incorrect options. Now let's check out this one. It says lanthanide and actinide. One is 6 and one is 7 period. We talked about this. So this part in here, I believe. Okay. On this one, you see the lanthanide and actinide. So lanthanide are here as it's shown in here, and this is sixth period, and actinide are in 7th period. You know, like this, the whole thing in here, it just fits in here into this 6th and 7th period. So those answers are correct. So the answer is C here. Now we're gonna move on to the second question. In here, it's all talking about the correct expression about nickel. It's a D block light metal located 4th period, atomic number 58.7, mass number 28, and it's considered to be transition metal. Now we're gonna go back into here. We know that the transition metals are D and F elements, and the D elements are here. Let's find our nickel. So nickel is right here. We got the 28 atomic mass, and 58.7 is atomic mass number, 58.7. And then what's the period? 1, 2, 3, 4th period we have in here. So we said that it is on 4th period, so this is correct. It's a D block, it is correct. D block elements are transition metals, it's correct. Atomic mass is 28, and there's actually a mistake in here. So this one is not mass number is not 28. Mass number is 58.7, and atomic number is 28. It's either way around, so these are incorrect. And whether it's a light metal or non-light metal, we're gonna check it out right now. So you guys remember from the scoring package that these two group elements, they are light metals as it's shown in here, but the other one circled, put in the black box, they are heavy metals. Okay, so because nickel is in this black box, we're gonna call it a heavy metal. So you guys need to kind of, do your homework when you recognize what elements are low melting point, ductile, and we have brittle in here. Brittle, ductile. You need to be able to recognize them, because we're gonna just give you an empty periodic table like this, and then you're gonna find your own information from there. So now when we look back here, we know that it is not a light metal, so the answers are 1, 3, and 6. Okay, for the third question, we got match elements to their block in the periodic table. So let's find these elements that we have here. We have selenium, tungsten, cesium, and thorium. So let's locate them. We know that selenium is located here, and it's a P block element. And then tungsten is here, it is a D block element. And then cesium is here, it is S block element. And then we had thorium, I believe. and it's here, and these are F elements. Okay, so we're gonna go back to our answers. So we got here cesium is P block, so 1 is B, and then tungsten is a D block, so 2 is C, and then we got for cesium we got S block, it is A, and then 4 is thorium, it is F block element, which is A. Okay, so we're gonna move on to the next question here, which is about which element does not show similar properties compared to others. So if you look in here, we said that similar properties are happening around the same group. So you gotta be in the same column, same group, to have the same elements, same characteristics, right? So we got here lead, carbon, silicon, scandium, and tin. So let's look at the periodic table where we locate them. So if you look at on this group, so we got tin here. Okay, we got lead in here, we got silicon, we got carbon, we're all in the same group. Okay, and then look at where the scandium is. Let's find the scandium. Scandium is not in the same group. It is not in the same group, so we know that the scandium is 3B, is right here. So being on this side and this guy on the same group, they have the same common properties. So we're gonna choose scandium because it's not in the same group. Okay, so question 5, to which group family iodine is related? So we know that we divided these guys in here, from our SCORM package. So we got this group here, we got alkali earth, and then we got here, these are alkali and these are alkali earth metals. We got halogens here, we got noble gases in this group, and then we got some rare earth elements. So the most common ones are alkali earth, alkali and alkali earth, halogens, and noble gases. So let's go back in here, and then we find iodine. Iodine is located right here, which is halogens. Okay, so you guys really need to know the periodic table properly to answer this question. So 5 is gonna be A. Now we're moving on into the next question. It's telling us match the elements with their group families. So if you look back in there to halogens, you will see that bromine is in halogens, which is here. So you see the bromine is in halogens. And then if you look at neon, it is inside the noble gases. And then we got beryllium, you see it is inside the alkali earth. So we choose those answers. So neon goes for noble gases, and then beryllium goes to alkali earth. So 1 is C, 2 is A, and 3 is B. Okay. Choose the correct expression for the 7th question about sulfur. Sulfur is a light metal, transition metal, semi-metal, non-metal, radioactive element. So if you look into the periodic table, we had here, you see we had this differentiation. This is one of the important ones. So you need to know where these are light metals, these two groups in here, alkali and alkali earth. We have this here, we have this big black box with the D block elements of metals, and then we have here metals again on this side, but they're low melting point metals like this guys. The part in here, they are semi-metal, so semi-metal, and then the part like in this yellow, you see this part without the lines on them. I'm gonna make it using like this. So you see this part, this is non-metal. Okay, so this is a non-metal part, non-metal. Okay, so if you look at sulfur sulfur in here inside the non-metals. Okay, so we're gonna go back to our questions and we're gonna check the non-metal or sulfur. Question 8, match the properties of metals and non-metals. So if you look at here for the question 8, we said most of the stuff, among all elements of this type, only one is liquid. Do you remember we said the mercury is only liquid, which means that among all of the elements, only one is liquid. That means that it is for metals. So one is gonna be A. And then we got majority of all chemical elements are of this type. If you look at into periodic table, the way we divided the metals, like these are, for example, these guys in here, they are metals. And then these guys in here, they are metals too. And then we're gonna choose these guys here, they are metals as well. But these guys are semi-metals. And then these guys in here, they are non-metals. So most of the stuff we have is metal. So then we're gonna go back in here, we're gonna choose majority of elements of this type are metals, so one is again the B. And then for 2, they usually obtain electrons rather than lose. We know that this is a non-metal characteristics because non-metals have higher electronegativity. Okay, now let's go back into the periodic table for this one. I know that electronegativity increases as I go up and as I go right. So electronegativity increase. Electronegativity means like obtaining electron. Okay, so because if we go towards the right, you see our non-metals are in here. So non-metals tend to obtain electron, but the metals tend to lose electron because they have a lower electronegativity. If you see my metals are located are on this side, but my electronegativity increases as I go towards right, towards non-metals. So non-metals will gain electron. So for this part we have 2, we're gonna have C for non-metals. It says that can be deformed if beaten. We know that from our lab, if we beat the metal, we can change its shape. It's not broken. So it is going to be a non-metal characteristics. And then they have a higher electronegativity than any other type of elements. I just talked about it. Non-metals have always higher electronegativity. So 8 is going to be like this with the answers. So for question 9, I'm going to be talking a little bit about our definitions. I won't just give you a simple explanation, but I will show you what they are. So definition, ionization energy. Ionization is what? When you're an atom, right? And then you put energy inside this atom, like you heat it up or you do something, and it makes ion with a plus charge. And then it loses electron. You see, as a product, electron got separated, so we made ion. Now this energy is called ionization energy. Okay, to make this ion, I needed this energy. This is called ionization energy. So 1 is gonna be C in this case. And then electron affinity. Now the other way around. So atom, for example, in here, this time is taking inside energy. When you add on top of an atom electron, it becomes negatively charged ion, right? Because electron is negative. And this time we're releasing energy. When you add electron, you release the energy. You see in here we input the energy, it's on the left side, but it's on the right side in here because we release the energy. The energy released when you obtain electron is called electron affinity. So that's why 2 is A. And now electronegativity is ability to add electrons of another atom to itself, like a withdraw electron or obtain electron from someone else. Okay, this is called 3 is gonna be B. Okay, so I want to show you guys the trend, and I want you to be able to memorize this. We have talked that electronegativity increases as you go from bottom to top and left to right. Okay, so this is the same for both ionization, electron affinity as well. So ionization energy, electron affinity, electronegativity, they all increase as you go from bottom to top and left to right. Okay, so this is very important. You need to memorize this. Now we're gonna go into the question 10. It says put the elements in the order increasing their electronegativity. The question just I talked about. So we have here oxygen, cesium, hydrogen, sodium, and fluorine. So let's locate this element. So we got here fluorine. Fluorine is both top and then high, right? So fluorine is the most electronegative. And then we look, oxygen is just beside fluorine. So oxygen is little behind. And then we look at sodium, cesium, and hydrogen. As we go up, electronegativity increases, right? So hydrogen is here, and then we got sodium, and then we got cesium. This is the order we have. So if we number them right now, this is gonna be cesium is gonna be first, and then we have second is gonna be sodium, and then we got hydrogen, and then we got oxygen, and then we have fluorine. Now on 11 it says that choose an element with the highest ionization energy. We said that ionization energy increases as you go up and from left to right. So if you look at these elements, we have magnesium, aluminum, phosphor, and chlorine, and argon. So if we locate these elements, is that magnesium is here, phosphor is here, but argon is here. You see, we said that as you go left and as you go up, argon is the most one on the right. So argon is gonna be the element with the highest ionization energy. The reason is that argon is a noble gas, right? Noble gas. We said that ionization energy is what? We said for one is energy required, right? Energy required. So argon is noble gas. Its octet is full. Octet rule is full. Because argon is a noble gas, it doesn't react. It's very stable. You need a lot of energy to ionize this guy, to lose electron, because all of the orbitals, they are full in this guy, okay? They're all full, and he doesn't want to lose any of the electrons. That's why you need a lot of energy to make the argon react. That's why. Okay, so now we're on question 12. It's telling us to choose the correct sentences. Let's start with the third one because it's super easy. It's saying that ionization energy of 18 group element is less than the first group elements. It is not right because we said that as you go from left to right, this is first group, this is 18 group, ionization energy increases. So this is not right. Ionization energy in the second one, it says that increases down the periodic table. It's not right because we said that as you go up, it is increases. So this is incorrect as well. So for the first one, it says the second ionization energy of magnesium is greater than the first. So we know that the magnesium is a second group element. Okay, so second group element, magnesium has 2 electrons to lose. Magnesium has 12 atomic numbers, so it goes 1s2, 2s2, 2p6, and 3s2. So these are our 2 electrons that we lose. When you lose 1 electron, you become magnesium plus and then 1 electron. And then you lose one more, you become magnesium plus 2, and then this is the second electron, okay? So first ionization energy is always going to be, like E1 is always going to be lower than E2, because the first electron gets out super easier, but the second one gets out a little harder than the first one. That's why it's going to be the first answer in here, and then it's going to be C. In here it's telling us for the question 13 that difference between first and second ionization of energy, of which element is the greatest. The only thing in here you need to do is to find the group numbers of this, guys. This is a 2A, this is 1A, this is 3A, and these guys are in sulfur and silicon. Let's find them out. So we got sulfur in here and silicon here. So 4 and 6A. So 4A and 6A. If you look among them, potassium is the one with the lowest amount of electrons to lose. So if you lose that, potassium loses that 1 electron, becomes positive 1, right? And this is the stable situation because he only had 1 electron to lose. You know that potassium electronic configuration is 19. So it's 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s1, right? This is that 1 electron. But then to lose the second electron, it needs to get into this third shell, which is really stable, and we don't want to go there. That's why the only answer is in here is 13B. But if you look calcium, it's easier to lose because he has 2 electrons to lose. Aluminium the same way, sulfur same way, silicon same way. It's really easy to lose the second electron. But for potassium, no, it's not the same. Now we'll look on the question 14, why atomic radius of an element of the same period decreases with the number of electrons at the last shell. Okay. About the atomic radius, I wanted to talk about this quickly. So I said that, actually Dilara Khanum said that about the atomic radius in the scorn package. Atomic radius in periodic table is increasing from right to left and then from top to bottom. So you have here hydrogen, and then as you go down it starts to increasing, like we have a bigger one in here. The reason is you have more electrons, like, and electrons are negatively charged, right? We have negative and then negative. When you have more electrons, they start to kicking each other out, and that's why you become, and the more electrons you have, the more bigger radius you're getting, okay? Because of the repulsion, and that's why the only answer in here, because the repulsion among electrons is increases along the periods, okay? And then the same way I just wanted to wrap this up. So atomic radius is starting to decrease from right to left because as you go right, electronegativity increases, right? Electronegativity is what? Withdrawing electrons, obtaining electrons, right? If I get more electrons, that means that I take it inside, like I just withdraw it closer to my nucleus. So that's why when you go towards the right, atomic radius decreases, but when you go from right to left, atomic radius increases. So if you started from this one is super small, and then it becomes a little bigger, and bigger like this, Okay, so bigger in here. Now question 15, choose the element with the biggest radius. From here we see that it's all about chlorine, right? But this one lost 7 electrons, this one lost 5, this lost 3, this didn't lose anything, and this one gained electron. As I said, that because electrons are pushing each other because of the repulsion, the one which has the most amount of electrons, which is this guy, chlorine, negative, which is 17 and it has 18 electrons, is going to have a biggest radius because it has the most amount of electrons to deal with. So that's why the answer is 15.